I want to show you something that might permanently change how you see the night sky. Because the universe is not crowded, it is horrifyingly empty. If the sun were shrunk down to the size of a tiny marble sitting in your hand, do you know where the nearest star would be? Not across your room, not even across your city. You would need to travel hundreds of kilometers just to find the next marble. And once you finally see that distance visualized, once you realize that two tiny marbles would sit nearly 400 kilometers apart in total darkness, you'll understand something terrifying. Humanity is not living in a neighborhood of stars. We are stranded on a microscopic island, floating in an ocean of emptiness so enormous. Your brain was never built to truly comprehend it. I'm going to make you feel something you've never felt before. Not fear, not wonder, loneliness, cosmic, gut-wrenching, existential loneliness. Because by the end of this video, you're going to realize we are not floating in a neighborhood of stars. We are stranded in an ocean of nothing. And the distance to our nearest neighboring star is so obscenely vast that when you actually see it visualized, you're going to feel it in your chest. Let's find out just how alone we really are. Pick up a marble. Any marble, one of those little glass spheres about 1.27 centimeters across. Hold it, look at it. That marble right there in your hand is the sun, not a symbol, not a metaphor. If you took the actual sun, all 1.39 million kilometers of it, and shrunk it down, it would become this marble, 1.27 centimeters wide. That's our scale. Everything from this point forward gets measured against that tiny glass sphere. Now here's the question that's going to break your brain. Where is the nearest star? Not a planet, not an asteroid. Another sun, another marble, burning somewhere else in the dark. How far away is it? Across the table, across town, across the country? Whatever your instinct says, you're wrong. And when I show you the real answer, you're going to understand why interstellar travel is so terrifyingly difficult. Let's lock in the numbers. The real sun has a diameter of about 1.39 million kilometers. Our marble sun is 1.27 centimeters wide. That gives us a scale ratio of roughly 109 billion, meaning 1 centimeter in our model is about 1.09 million kilometers in reality. Or more usefully, 1 meter in our model is about 109 million kilometers in reality. Almost the distance from the Earth to the sun. Remember that number, because now we're leaving the solar system. The nearest star system to the sun is Proxima Centauri. Distance 4.24 light years. A light year is the distance light travels in 1 year, about 9.46 trillion kilometers. So 4.24 light years equals roughly 40.1 trillion kilometers. Now convert that into our marble model. 40.1 trillion kilometers divided by 109 million kilometers per meter equals about 368,000 meters. That's 368 kilometers. If the sun is a marble in your hand, the nearest star is another marble 368 kilometers away. Not across the room, not across the city, hundreds of kilometers away. That's roughly the distance from Mumbai to Goa, Los Angeles to San Francisco, London to Paris, a marble, and another marble, separated by nearly 400 kilometers of emptiness. That's our stellar neighborhood. Let that breathe. Pause for a second. Really think about that. The sun, our sun, becomes a marble, and the nearest other star is another marble hundreds of kilometers away. Everything between them is almost completely empty. No breathable air, no glowing clouds, no busy traffic of spaceships, mostly vacuum, a near-perfect void. If you started walking from the sun marble toward Proxima Centauri at 5 kilometers per hour without stopping, it would take about 74 hours to get there. 3 straight days of walking toward a single marble. That's how isolated stars really are. Now let's talk about light. Light is the fastest thing in the universe. Nothing travels faster. At our marble scale, where 1 meter equals 109 million kilometers, how fast does light move? Real light speed is 299,792 kilometers per second. At our scale, it comes down to about 0.00275 meters per second. That's 2.75 millimeters per second. Light, the fastest thing in existence, moves slower than an ant in this model. You could literally watch it crawl. And to cross the 368-kilometer gap between the Marble's light would still need 4.24 years. Even the universe's speed limit struggles to cross interstellar space. Now, let's make this painful. Voyager 1 launched in 1977. It is the farthest human-made object ever sent into space. After nearly 50 years of non-stop travel, Voyager 1 is about 25 billion kilometers from Earth. It sounds enormous, but at Marble scale, it is only about 230 meters away. After almost half a century, Voyager 1 has only traveled about 2 city blocks away from the Sun Marble. Meanwhile, the nearest star is 368 kilometers away. At its current speed, Voyager 1 would take roughly 73,000 years to pass near Proxima Centauri. 73,000 years. Longer than all of recorded civilization. That is not exploration. That is exile into the void. Now let's place the planets. Maybe this will make the solar system feel less empty. At our Marble scale, Mercury sits about 53 centimeters from the Sun. Venus is roughly 99 centimeters away. Earth is about 1.38 meters away. Mars is about 2.1 meters away. Jupiter is about 7.1 meters away. Saturn is about 13 meters away. Uranus is about 26 meters away. Neptune is about 41 meters away. So the entire planetary system fits comfortably inside the size of a basketball court. And after Neptune, there is nothing for another 368 kilometers until the next Marble. There is one final structure surrounding the solar system, the Oort cloud, a gigantic spherical shell of icy objects and dormant comets. It extends outward to perhaps 100,000 astronomical units from the Sun. At our Marble scale, that outer edge reaches roughly 138 kilometers from the Sun Marble. So even the outermost gravitational edge of our solar system only gets about 1/3 of the way to the next star. There's still more than 200 kilometers of emptiness remaining. A giant cosmic gap where almost nothing belongs to anyone. Now let's zoom out even farther. The Milky Way contains roughly 100 to 400 billion stars. Let's use 200 billion as a middle estimate. The galaxy itself is about 100,000 light-years across. At Marble scale, that becomes about 9.2 million kilometers wide. Not 8,000 kilometers. 9.2 million kilometers. That's over 700 times the diameter of Earth. Roughly 24 times the distance from Earth to the Moon. And scattered across that gigantic volume are 200 billion tiny marbles. Sounds crowded? It isn't. Most stars are still separated by huge distances. The galaxy isn't packed. It's sparse, a desert of darkness with isolated islands of light. Now imagine actually trying to visit Proxima Centauri yourself. Let's say humanity somehow builds a ship capable of traveling at 10% the speed of light, about 30,000 kilometers per second. Absurdly fast, far beyond anything we've ever built. At that speed, reaching Proxima Centauri would still take over 42 years from Earth's perspective. You leave Earth at age 20. You arrive in your 60s, and when you finally get there, you don't find paradise. You find a dim red dwarf star, cold, violent, probably hostile to life. Then you turn around. Another 42 years home. Everyone you knew is gone. Your civilization changed without you, and all you accomplished was crossing the void. Here's what science fiction really tells you about interstellar travel. The worst part isn't speed, it's isolation. You're trapped inside a metal shell for decades. No rescue, no help, no civilization outside your walls. Just silence and darkness. And distance so enormous your brain can't emotionally process it. Space doesn't merely separate worlds, it isolates minds. So here's what we now know. If the Sun were a marble, the nearest star would be 368 kilometers away. The planets would fit inside a basketball court. The Oort cloud would stretch across a city, and the galaxy itself would span millions of kilometers, filled with lonely marbles separated by impossible emptiness. We are not living in a crowded universe. We are living in an overwhelmingly empty one. A universe where even light needs years to travel between neighboring stars, and we, tiny, fragile creatures on a small rock, are stranded around one of those marbles. But here's the beautiful part. That isolation is exactly what makes life extraordinary. Out of hundreds of billions of stars, this is the only one we know with life. The only one we know where matter became conscious enough to ask questions about the universe. The only place where someone picked up a marble and wondered how far away the next sun was, and then figured it out. That's not insignificant. That's miraculous. We are alone, but we're aware of being alone, and that awareness changes everything. Next time you see a star in the night sky, remember it's another marble, hundreds of kilometers away in this tiny model, separated from us by a nearly incomprehensible ocean of emptiness. And strangely, that emptiness is what protects us. If stars were packed closely together, planetary systems would be unstable. Radiation would sterilize worlds. Stars would disrupt each other gravitationally. The void makes life possible. The loneliness keeps us alive. And the fact that you can look up and see those distant marbles glowing across the dark is one of the most extraordinary things in existence. If this made you feel the weight of cosmic distance, send it to someone before tomorrow's upload. And if you want another reality-breaking perspective, tomorrow, subscribe now, because we're just getting started.